Next up, we have Vitalik joining us virtually. And the topic for the talk today for Vitalik is the importance of open source in Ethereum. Okay, found like a screen. Yeah, it's on. All right, say hi, Taipei, to Vitalik.
Yes, hello. Yeah, it says host disabled participant screen sharing. Can you enable that so I can have my slides?
Yes, I'm on it. All right, and I'm going to record this
I
as
see
well.
it.
Recording in progress.
Please take it away.
Okay, so good afternoon, everyone. So the topic that I wanted to talk about today is one that is somewhat less technical than the things that I talk about and more philosophical, but I think it's still one that's very important given the unique nature of what open source or what Ethereum is and what blockchains are and the technology that we're working on is here for. And in particular, how it affects some of the choices that different projects in the ecosystem can make. So I think what's interesting about Ethereum is that there are a lot of different ways to talk about it. And I think all of these different ways are valid and they represent different ways of coming at the same thing. So the one that I think people who have been in the space for the longest time have heard of is this idea that Ethereum is a blockchain, but it's a blockchain that is programmable, but general purpose, right? So people who have been around for many years might remember the presentations that I would give in 2014, 15, 16, and 17, where I would have three objects. I would have a pocket calculator, which represents Bitcoin. It's a thing that is designed to do exactly one thing and to do that one thing well. Then you would have a Swiss Army knife, which is designed to do many things, but still designed to do a limited number of things. And then you have a smartphone, which can do a much, much wider array of things. And if you want to do some new thing on top of a smartphone, then you can express that thing as a piece of code. And the smartphone can just run that code, and that's an application. So Ethereum tries to bring that same spirit of being programmable and general purpose to the world of blockchains. And I think this is how Ethereum has been described very often historically, but it's only one of the perspectives that you can come at Ethereum with. Another interesting perspective is looking at it as open source software, but with a shared hard drive. Right, so open source software, or also free software, is a movement that has existed for about 40 years now. And it's a reaction to a trend that started in the late 1970s, where companies would start creating proprietary software where the compiled binary version would be made available, but the underlying source code would be kept hidden. And so they would even use copyright law to go after people who tried to share the program. And so what the problem that they saw with proprietary software is that you have something that is on your computer and something that is very critical to your productivity and to your personal life, to your increasingly just ability to exist and do the things that you want to do as a person. That is totally not under your control, right? And this is not something that was really possible before in the same way. If you buy a car, you can go personally and repair the car, you could go and modify the car. If you buy a thing from a hardware store, you can pick it apart, you can understand how it works, you can use that knowledge to try to build other things. And for most of human history, these things were taken as a given. But then with proprietary software, suddenly you had a thing that is on your computer and that is responsible for very personal and just very important things that you're doing, but which is not serving you. It's serving some corporate master that exists somewhere else thousands of kilometers away. And what people like Richard Stallman said is like, let's have a movement that tries to explicitly go against this. Let's have a movement of people who write code and openly publish it, openly publish the source code so anyone can see how it works. They can verify that it works in the way that the developers say that it works. They can even modify the source code. They can make other software on top of it, and basically create this open and collaborative ecosystem where people would be building on top of each other instead of building totally independent things in silos that are competing with each other. Now, the open source software is great, but in the 2000s and in the 2010s, I think in many ways the movement succeeded, but in many other ways it hit a wall. And what that wall is basically that today, the kinds of things that we do on our computers are not things where you do something on your computer and it stays on your computer. It's things that involve collaboration, often very large scale collaboration, lots of people doing things with each other over the internet, people building things on top of other things, people replying to each other, people collaborating with each other. And these are things where even if the software is theoretically open source, it still has to live on a server. And the control is not with the code, the control is with the server. And if someone has that server, then they can use that to exclude who can and can't participate. They can use that to charge high fees. They could use that to even first get a strong network effect and then exploit it and charge very high fees. They can change the terms arbitrarily. They can spy on every single thing that you're doing. They have a lot of power over you that did not even exist even in the kind of wildest proprietary software dystopias that people in the 1980s and 1990s were trying to avoid. And so the question is, like, can we take the ideals of open source software and can we update them to this environment where most of the important stuff is collaborative? And so the way to think about blockchains are it's open source software, but with a shared hard drive, right? When you have people collaborating and replying to each other's messages, when you have people creating assets like tokens, when you have usernames that people use to refer to their accounts and their names, when you have all of these things, you need to have like some shared space where everyone can agree on the contents of the data stored in that shared space for these collaborative applications to run. And this is what blockchains were trying to do. And I think this vision of open source software with a shared hard drive is something that was very influential in the early days of Ethereum. So people who were around near the beginning, again, might remember Gavin Wood, one of the co-founders, was very big on this vision of Web3, right? The idea that like this would be a new generation of the World Wide Web. And he really had a vision of Ethereum being not just financial technology, but Ethereum being a thing that exists in this tradition of open source software. So this is another way to look at what it's trying to accomplish. A third way to look at what it's trying to accomplish is social institutions with hardness, but on the internet, right? So what do we mean by hardness? Basically, physical hardness is things like castles, things like walls, things like cities, things that are designed to be very defensible and things that are designed to stick around for a long time. If you build a house inside of a city, you know that your house will be defended, and you know that the city is not just suddenly going to move somewhere else one day, right? You know that you have this like very strong and durable ability to build on the foundations and the infrastructure that the city provides. Money is something that's hard. Money is a social institution, and money is something that ultimately only exists in our heads, right? National borders are another one of those things that ultimately is just a thing that collectively exists inside of people's heads. But like these things are very meaningful. And when these things are done well, which they definitely not always are, then like they can provide this foundation of stability for people to build lives and businesses on top of that is as real as what's provided by things like physical castles and walls. And now the question is, like, can we update this concept of social institutions that have hardness to the internet age, right? And we have tools like cryptography, we have tools like blockchains, and we actually are able to create things like cryptocurrencies, things like decentralized domain name systems, and all of these things where even though they theoretically are just bits that are flying around the internet, they still feel like things that are very hard and things that are very difficult to change. So Ethereum is all three of these things. Blockchains in general are powerful because they're not controlled by any single individual. They're not controlled by any single corporation. They're not controlled by any single government. They're not controlled by any single political tribe. They are there for all, even for people that I disagree with. Being on a blockchain means any application you create will not be shut down arbitrarily. Your transaction will not be censored. The rules will not change on you at a moment's notice. And no one can edit the database to steal or take away your digital money or your digital monkey. So that's those are some of the ideals of blockchains, right? But these ideals do not propagate themselves automatically. So this is a chart of MEV relays, which are a piece of infrastructure that is in the pipeline of taking transactions from users and packaging them into blocks. And in late 2022, we had this crisis where a very large portion of these relays started censoring a lot of transactions. There was a big community backlash against this, and a lot of people lobbied very hard talked to these relays, talked to people to set up new relays, did all kinds of things. And after a very long and successful campaign, the percent of MEV relays that are censoring went down from a peak of about 80% to where they currently are, which is at about 30%. So this is a big success. This is a big success of the ideals of censorship resistance defending themselves, but they were not defending themselves. They were being defended by an active community that cares about those ideals. And I think it's important to not understate the importance of this community layer and how if the community layer was different, these ideals could easily be very weak, right? And this is also actually a debate that happens in Bitcoin from time to time as well. So I believe the recent scandal is that I think Luke Jr. wanted to start using his mining pool to censor ordinals or something like this. There's lots of individual pools that exclude certain types of transactions. And if there isn't a social layer that is hostile to those kinds of things, then once 60% of the miners start censoring, then the chain starts censoring, right? And this is something that's difficult to recover from. In proof of stake, we actually have more tools that allow a community to effectively recover from a 51% attack and even penalize pretty heavily anyone who participated in the 51% attack. But even still, this security of these ideals and these properties of blockchains uphold really depends on community. Ethereum client centralization. Clients are pieces of software that people use to interpret the Ethereum protocol rules and validate the chain. And one of the types of decentralization that Ethereum values is having multiple clients be available. This is something that both is helpful for the system's political decentralization because it allows, it decreases the amount of power that any one single group of developers has. But it's also good for the security of the network. There was a big, long event that happened in late 2016 that was called the Shanghai DOS attacks. It was called that because the attacks started literally 3.5 hours before the beginning of DevCon 2 in Shanghai. And what happened there was basically that there was an attacker who did a very good job of finding a huge number of bugs in the two main clients at the time, Geth and Parity, that severely slowed down their ability to process blocks and in some cases even stop them, right? In some case, like these were what are called denial of service attacks. They often basically forced block processing to take up a really, really huge amount of memory, sometimes like 40 gigabytes or something like this. And the Ethereum network was definitely slowed down by a lot. The gas limit had to be temporarily reduced even to 500,000 for some period of time. But the Ethereum chain never stopped. And the reason why it never stopped is because there were two clients, and whenever one client had a bug that stopped it completely, the other client was still able to function. And so lots of people were switching back and forth between Geth and Parity, but even still, the existence of the two clients helped the Ethereum chain survive this period. Now, this is something that needs to be actively maintained, right? It's very easy for the network to kind of collapse into an equilibrium of everyone running the same client. And in some cases it has. And when that happens, then people who are working on any other client get demoralized. Often development falls behind further, and the equilibrium can easily become very sticky. There was a large push about 2 years ago to really improve client diversity on the side of consensus clients, which interpret Ethereum's proof of stake rules. And client diversity has improved massively, with the largest client decreasing from about 80% market share to about 43%. On the execution client side, things are less good, but things have still improved. Clients like Nethermind and Besu have improved massively over the last few years, and they've become more and more usable as fully fledged Ethereum clients that people can go and use. And now we have either had Aragon, we have Reth, and there's an increasingly large array of clients that are available. But as we see on the chart, there is still more work to be done. Ethereum global node distribution. So this is a graph of the Ethereum nodes and how they're split up across the world. And we see a lot of nodes in the US, a lot of nodes in Europe, some in East Asia. One of the dots, I mean, if you look at there's like 5 dots in East Asia, and sort of the little one that's in between Hong Kong and Seoul, that's like Taiwan. And so you guys are definitely right up there and visible, but there are still many big parts of the world that are not visible at all, right? And this is another one of those things that I think it becomes really important to try to continue improving further. Openness and account abstraction. Account abstraction is one of these new standards that is being developed in the context of Ethereum, which basically allows people to use EVM code to define the rules that protect their account instead of having a single private key define those rules. This enables a lot of improvements in security, convenience, and quantum safety, a lot of other features. ERC-4337 is sometimes criticized for being complex, but simpler variants generally have hidden trust assumptions, right? So this is a diagram of the main part of ERC-4337. And here you have basically a verify and pay phase where there is an entry point contract that first calls every single wallet and checks the signature and pays fees. And then you have an execute operation and refund phase where the entry point then actually does the executing and then does the calling a refund. You might ask, why this complexity? Why not just do a single call? The reason why this complexity exists is to make sure that a public mempool is possible, right? So what do we mean by this? When you send a transaction in Ethereum today, that transaction goes into a public peer-to-peer network, and then anyone who is building a block can download it. Now, this is only possible because for any transaction that a user creates, there is a very simple and very fast procedure for verifying that transaction. And so anyone in the network could just verify a transaction and pass it on. The problem with a lot of more naive account abstraction proposals is that they remove this guarantee and they create a situation where a big transaction might potentially require a really, really huge amount of computation to verify. And if the verification fails, then whoever was trying to include that transaction does not need to pay any fee at all, right? And so making sure that it's very quick to verify whether or not a transaction is guaranteed to pay fees if it gets included is this very important property that ERC 4337 tries very hard to achieve. And this property is really key to ensuring that a public mempool is possible. And so transactions can get broadcasted through this open network where anyone can come in and participate. Openness and cross-layer 2 swaps. So these days, it's becoming more and more important to try to be able to swap and move coins between different layer 2 networks. These days, most layer 2 tokens are done by these commercial protocols that often have very bespoke trust assumptions. There are better alternatives. So this is Uniswap X. It's a paper and a project done by the Uniswap protocol that allows for a permissionless marketplace that allows anyone to just create a message saying, I want to convert this number of coins on this chain into this other number of coins on this other chain. And you can have swappers that accept those orders. And there are trustless mechanisms that use cross-layer 2 verification to actually make sure that the swapper gets compensated if they actually fill the deal on the other end. So there's many open standards that are very important. ERC 1271 and 6492, which allows smart contract wallets or account abstracted wallets to also make off-chain signatures. ERC 4337, account abstraction. ERC 6900, which are modular wallets, basically which would allow each individual wallet creator to write much less code. And whatever you need to write less code that makes everybody more secure. You have ENS as a domain name system, it's much better to just rely on ENS than to try to roll your own name system. And then you have ERC 3668, which is the CCIP protocol, that is a standard that allows ENS names to exist on layer 2s and for ENS subdomains to be issued and transferred and verified, all without touching layer 1s and all without requiring trusted intermediaries. So there's lots of these very powerful open standards that are important, and these are both standards that exist already, but also standards that are being developed. There are other standards that will continue to be developed in the future. For example, as the privacy situation on Ethereum improves, there will need to be more standards for how to store users' data, because users' wallets are going to be not just stores of tokens, but also stores of data. And data needs to be stored differently, because data doesn't live on the blockchain. Data needs to be stored by you and only seen by you. So there are more kinds of standards that will be developed and that will be important. And I think it's very valuable for projects to be aware of and participate in both these standards that exist and even actively help to shape these standards that are being developed tomorrow. So the core message that I want to leave people with is basically build tools, not empires, right? The way that the centralized world works is you win by building the biggest empire, and you make a really massive profit from building the biggest empire. But in a decentralized world, if you build an empire, then ultimately you are centralizing control and you are compromising on the really key things that make blockchains be what they are. And so I think the philosophy that works much better for decentralized networks is to focus on building tools, build things that do a particular thing and do it well, but that exist in the context of other things that are being developed by other people, and that can be easily used at the same time as other things that are being developed by other people. Basically being part of a bigger ecosystem instead of trying to grab a big pie for yourself. And if more people in the community actively take this approach, then the Ethereum ecosystem grows stronger, and ultimately this benefits everyone. So that is the message that I hope that that I wanted to give, this is something that I think a lot of people have been doing a better and better job of over the last couple of years, and I hope that as Ethereum goes through these complicated transitions this year, this kind of spirit can continue and grow further. So, thank you.
Thank you. Thank you, Vitalik, for joining us at Taipei Blockchain Week. We hope to see you in person in Taipei next time. Before we let you go, I know it's super early or late where you are, so really appreciate you for joining us. So before we let you go, please
Yeah.
say bye to the
Thank you,
audience in
guys.
Taipei and maybe tell us your favorite Taiwanese dish. Okay, that's okay. We hope to see you in Taiwan next time. Thank you, Vitalik.
So,
Say bye.
okay, guys, thank you. And see you guys in Taipei soon.
All right. Bye-bye. Thank you. Let's get it up for Vitalik.
Yeah.